GenAI and MLOps Part 15. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. MLOps situation. Data pipeline delay. Training data is delayed by 6 hours and a retraining job is about to run. How do you decide whether to proceed, skip, or use older data? Here's a strong way to approach it. Check whether the retraining job requires the delayed data for correctness or whether older validated data is acceptable under the model's freshness law. If freshness is critical, skip or hold the run and alert the data owner. If the model is robust to lag, run with the last complete validated snapshot and clearly tag the data version. The key is to avoid silently training on partial data and to make freshness checks part of the pipeline gate. Nice. Let's continue. Question 2. MLOps situation. Silent schema change. An upstream team changed a column meaning without changing its name. How would you detect, mitigate, and prevent this? Here's a strong way to approach it. Detect it through distribution checks, feature importance changes, business KPI shifts, training serving SKU checks, and contract tests that validate semantics where possible, not just column names. Mitigate by rolling back or disabling the affected feature, retraining only after data is corrected, and notifying the upstream owner. Prevent it with data contracts, ownership, change review, feature documentation, and alerts on statistical shifts even when schema technically remains valid. Great, moving on. Question 3. MLOps situation. Feature drift alert. Drift monitoring fires during a holiday sale, but revenue is up. How do you avoid a false incident while still protecting the model? Here's a strong way to approach it. Treat drift as a signal for investigation, not automatic rollback. Check whether the drift matches an expected business event. Compare model quality or proxy metrics by segment, and verify error rates, confidence, and downstream outcomes. If business impact is positive and quality signals are stable, downgrade to watch mode while documenting the event. If sensitive segments degrade, limit traffic or add guardrails for those segments. Alright, next question. Question 4. MLOps situation. Model serving outage. A model endpoint returns 5xx errors after scaling from 5 to 50 replicas. How would you debug it? Here's a strong way to approach it. Check deployment events, pod logs, readiness failures, image pools, resource limits, model load time, shared dependency limits, database or feature store connections, and whether all replicas can access the model artifact. Large scale-ups often expose bottlenecks in startup, artifact download, file descriptors, connection pools, or quota. Mitigate by rolling back scale, increasing min-ready time, preloading artifacts, tuning dependencies, or adding back pressure. Let's keep going. Question 5. MLOps situation. GPU quota shortage. A critical training job cannot start because GPU quota is exhausted. What immediate and long-term actions would you take? Here's a strong way to approach it. Immediately check for idle or lower priority GPU jobs to pause. Move the job to another region or machine type if compatible. Reduce parallelism, or run a smaller emergency training job. Long-term, add GPU quota monitoring, priority classes, team budgets, reservations for critical workloads, spot or preemptible pools for non-critical experiments, and scheduling policies so important jobs are not blocked by ad hoc experimentation. On to the next one. Question 6. MLOps situation. Model artifact corruption. The registry points to a model artifact that cannot be loaded in production. How do you recover and prevent recurrence? Here's a strong way to approach it. Recover by redeploying the previous known good model version and verifying the artifact URI, checksum, permissions, and environment compatibility for the broken version. Prevent recurrence by making registration atomic, storing checksums, running a load test before promotion, keeping artifacts immutable, scanning or validating model packages, and preventing manual overwrites of production artifact paths. Good. Here's another one. Question 7. MLOps situation. Rollback conflict. Product wants to keep a faster model, but risk wants rollback because accuracy dropped. How do you lead the decision? Here's a strong way to approach it. Frame the decision around agreed release gates and user or business risk, not opinion. Show the latency gain, accuracy drop, affected segments, confidence interval, blast radius, rollback time, and alternatives such as partial rollout or feature flagging. If the model violates an approved guardrail, recommend rollback or limited traffic while a fix is prepared, and document the decision with product, risk, and engineering ownership. Nice. Let's continue. Question 8. MLOps situation. Missing ground truth. The business asks for model accuracy monitoring, but labels arrive after 30 days. What proxy signals and workflow would you design? Here's a strong way to approach it. Use proxy signals such as prediction distribution, confidence scores, input drift, business funnel metrics, manual review samples, user feedback, and rule-based anomaly checks until labels arrive. Build a delayed label evaluation job that backfills true quality metrics after 30 days, compares against the champion model, and updates dashboards. Be explicit that proxies do not replace ground truth. They are early warning indicators. Great. Moving on. Question 9. MLOps situation. Training serving skew. Offline validation is strong, but online predictions are poor. How would you prove or rule out training serving skew? Here's a strong way to approach it. Log the exact online features used for predictions and replay a sample through the offline pipeline to compare values, transformations, defaults, encodings, timestamps, and missing value handling. Check whether training and serving use the same feature code and data sources, and compare distributions by feature. If skew is found, fix the shared transformation or feature store path and add automated parity tests before deployment. Alright, next question. Question 10. MLOps situation. PI leak risk. You discover raw customer data may be logged in model training or inference logs. What is your response plan? Here's a strong way to approach it. First, contain exposure by disabling or redacting the risky logs, restricting access, and preserving evidence for security review. Identify affected systems, time range, data types, and users with access. Then involve security or privacy teams for incident classification and notification requirements. Prevent recurrence with PI detection, redaction by default, least privilege log access, retention limits, and tests that fail builds if sensitive fields are logged. Let's keep going. Question 11. MLOps situation. Expensive experiment culture. Data scientists are launching many large training jobs without cost ownership. How would you introduce guardrails without blocking innovation? Here's a strong way to approach it. Start with visibility, labels, dashboards, per team budgets, and cost by experiment or model. Then add soft guardrails such as default smaller machines, max runtime, quota warnings, spot or preemptible pools, approval for very large jobs, and reusable templates that make efficient choices easy. Keep a path for justified large experiments, but require ownership, expected value, and cleanup. On to the next one. Question 12. MLOps situation. Notebook to production. A data scientist has a high-performing notebook model. How do you turn it into a reliable production pipeline? Here's a strong way to approach it. Extract the notebook into versioned modules. Define data contracts. Package dependencies in a container. Create reproducible training and evaluation pipeline steps. Log metrics or artifacts. Register the model only if it passes gates. And deploy through a controlled serving path. Add tests, monitoring, rollback, ownership, and documentation so the result is not just a notebook result but an operable production system. Good. Here's another one. Question 13. MLOps situation. Flaky retraining pipeline. A retraining pipeline fails intermittently and teams rerun it manually. How would you stabilize it? Here's a strong way to approach it. Collect failure patterns first. Step, error type, data version, infrastructure state, time, and retry outcome. Add idempotent steps, retries for transient failures, stronger data validation, explicit resource requests, timeouts, checkpointing, and clearer error messages. Remove manual reruns by making rerun behavior safe and automated, and track pipeline success rate as and slow for the ML platform. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.